Hey guys, Mr. Grant here, and this is 7.5 Logarithmic Equations. So in this video, we're going to be solving by a few different methods. These are the different methods: converting to log form, converting to exponent form, applying what are known as one-to-one properties, and then applying our log properties. All right, so the first example, converting. When we've got something set up like this, it's fairly basic. One option is going to be just to convert it from either exponent to log form or log to exponent form. So if I start this one, number one here, by converting it to log form, what I'm going to get is this: log base 3 of 57 is equal to x. And the reason I did that, if this was 3 to the x equals 9, let's say, I could maybe just figure out that x is equal to 2. But this isn't going to be a nice one because 3 doesn't go to 57 with a very nice exponent. So I'm going to need to use the calculator on this. So we'll hit the math button, find our log base function, and then just type in the 3 and the 57 into the appropriate spot. And our answer is 3.68. So 3.68 for that one. Now something like this looks a little bit more complicated, but I could still see if converting it to log form will work. Let's see, so this would be log base 2 of 16 is equal to 3x plus 1. All right, now log base 2 of 16, can we simplify that? I think we probably can. If we need to use the calculator, we can. We could also think what exponent gets us from 2 to 16, and that is the exponent of 4. So we can replace the log base 2 of 16 with 4, and now we have 4 equals 3x plus 1, and now it's just linear algebra. We can subtract 1 from both sides. We'll get 3x equals 3, or 3 equals 3x. I guess if we keep things in the same order. And then just divide both sides by 3, and we get x is equal to 1. All right, our next one's log base 3 of x is equal to 4. Something like this, we could convert it into its exponent form to solve. So if we switch that around, this now becomes 3 to the 4th equals x. And 3 to the 4th, either plug it into your calculator, maybe you can figure this one out without your calculator, it's equal to 81. All right, and then the last one, same idea here. It looks like maybe if I convert this into its exponent form, that might work. So this is going to change to 5 squared equals 10x minus 5. And can I simplify anything? Yeah, 5 squared, I can replace that with a 25. So 25 equals 10x minus 5. And now it's another pretty straightforward algebra problem. We'll add 5 to both sides and get 30 is equal to 10x. And then if we divide both sides by 10, we're going to get that x is equal to 3. All right, our next example, solving with one-to-one properties. So our one-to-one properties are these: that if we have a to the x and we're saying it's equal to a to the y power, that means that x and y have to be equal to one another. Likewise, log base a of x equal to log base a of y, that only works if x and y are the same. So basically, if the base matches, you can just set either the exponents or the log parts over here equal to one another. Okay, so something like this. Log base 3 of 5x equals log base 3 of 10. We can really just sort of ignore or cross out the log base 3's on both sides and just solve 5x equals 10. If things match on both sides of an equation, you can usually just cancel them out. And we get x equals 2. All right, then on the bottom, number 2, log base 2 of this is equal to log base 2 of that. Well, the log base 2's, since they match, we can kind of ignore them. And now we can solve 2x minus 3 is equal to x plus 4. Again, pretty straightforward algebra. We could subtract the x from both sides. We could add this 3 to both sides. And what we're going to end up with, those things will cancel out, and we'll end up with x is equal to 7. All right, on the other side here, number 3, 2 to the x equals 2 to the 5th. Well, in order for this to match, x has to equal 5. The exponents have to match, so x is equal to 5. And then same thing with the next one. We can cross out the 5s and solve what is left. We've got x plus 9, the exponent on that side, equals 7x plus 3. And then same thing. Some two-step algebra. Subtract the x from both sides. We can subtract the 3 from both sides, and we'll get 6 is equal to 6x when things cancel out. And then if I divide both sides by 6, I get that x is equal to 1. All right, let's see. Using our log properties to simplify first and then solve. So this is kind of a combination of those one-to-one properties and then using the condensed and expanded log properties. So with this first one, looking at this, I can't go right into the one-to-one property because it's not really one-to-one yet, because it's a single log on this side and then more than one log on the other side. So before I can apply that one-to-one property, I have to condense this side. And so I can do that using my product rule. And that's going to make this log base 3 of 40 is equal to log base 3 of the product of 5x times 4. That is going to make this log base 3 of 40 is equal to log 3 of 20x. And now that we have the same log on both sides and only one log on both sides, we can cancel it out. And then now we're just solving 40 equals 20x. Divide both sides by 20, and we get x equals 2. All right, on the other one, this one we need to plug first. So that 2 is going to become the exponent of the 3. And so if we rewrite that, that's going to be log base 5 of 3 squared is equal to log base 5 of 3x. All right, now we've got our matching logs. We can cancel those out. A little bit of simplifying, right? 3 squared is 9 is equal to 3x. And now we can divide both sides by 3 and get x equals 3. All right, last one. Using log problems to solve some of these word problems, our exponential growth or decay word problems. So looking at this, we've got a population in town that increases by 7% each year. So it's increasing 7%. It's a growth formula. The initial population is 500. We want to know how long until it reaches 10,000. So if I set this up, my initial value is 500. It's 1 plus because it's increasing, so it's a growth, 0.07. And we'll put an x there for our exponent. And we want to know when is that going to equal 10,000. So here's how we can do this. We're solving for x. I'm going to start with the 500. Usually when you're solving for x, starting with the thing that's the furthest away is the right thing to do. So this 500 is the furthest away. I'm going to get rid of that first. So let's divide both sides by that. And I'm going to make this 1 plus 0.07 simplifies to 1.07. And that's just a little bit easier to work with in the next step. All right, and then 10,000 divided by 500 is not 50. It is 20. All right, so now I need to solve this. Well, this goes back to the first examples when we converted forms. If I convert this to log form, it is log base 1.07 of 20 is equal to x. And this is something that I can solve with my calculator. So again, hit the math button, our log base function, and 1.07, 20, hit enter, and 44 point, we'll round that to 28 is our answer. So 44.28 years rounded to the nearest hundredth of a year.